Stephen Lacey, Managing Editor of Green Tech Media here at the Grid Edge World Forum in San Jose, California. I'm joined now by Peter Knazko, who is the General Manager of the Smart Grid segment at Renesas Electronics. Hey Peter, how are you?
Good to see you, Stephen.
So Renesas is a leader in developing microcontrollers and microprocessors for all the devices that we use in our daily lives and in the industrial segment. And you're really pushing hard in the smart grid area and in smart meters and adding smarts to all the other equipment along the grid. Can you just give us a sense for the type of equipment that you're adding these microcontrollers and microprocessors?
It's a broad array of equipment, Stephen. The most important one for us is really the smart meter. The smart meter is a complex device, it does a lot of complex measurement, and then it provides a lot of complex data out. So we work with our partners to solve the various issues they have, the problems they have to get that data.
What are those issues?
Accuracy, it's a regulated industry, so the voltages and currents and phases have to be accurately measured so that the homeowners and the businesses are billed accurately, and so that's really what the smart meter enables, the utility to run the business side of the business, and to provide the electricity that's needed.
And how about some of the other equipment along the grid?
The communication from the various points within the grid, so as the data, which is all about what smart grid is all about, as the data is transferred through the network to enable the utility to control and monitor and protect the grid, we provide connectivity solutions, wireless and wired solutions, so that network is robust and stable and reliable.
In terms of the semiconductors, where are some of the most interesting improvements in integrating into these devices?
The big change has really been in the replacement of mechanical relays, mechanical switches with solid-state devices, which are high-power semiconductor devices. They last a lot longer, so that, they're extremely reliable, they're extremely fast, they're controllable remotely in a way that the older devices was difficult to control, and they can therefore integrate into networks, into intelligent systems in a way that wasn't possible before.
We're entering an era where buildings are starting to become grid actors, where homes can become grid actors,
yes,
where you have all these disparate devices coming together in a systems way, where they can interact with the grid in an unprecedented way. How do you envision that future unfolding?
I envisage it as continuing to be more integrated. That's really the interface at a world that was quite separate before. So the utility world, the world of managing the energy, and the home or the business, right now that action is taking place at that interface. So homes are becoming connected in a way that they never were, and in a way that feeds back to the utility, so the utility understands better the energy usage of their endpoints, which is either a business or a home, but also that home and business understands better their energy usage. So it used to be you got a bill and you try to understand your energy usage once a month when you got a bill. Now you can do it in almost real time, and that's a revolution. And as people see the benefit of that more and more, and as companies are able to provide pieces more and more, then that's just going to continue to grow. And I think that interface is almost going to disappear. So you'll have the endpoints creating energy and consuming energy, and utilities being more a partner rather than a supplier.
And we're not just talking about the grid, we're talking about cities, and
yes,
we're talking about large commercial industrial buildings and homes. So this is continuing to spread.
Yes, correct.
And you can basically put these microchips and the smarts in anything.
Absolutely. You can put them in absolutely anything. You can put them in the things you wouldn't even consider. If we think of how plants grow, there are sensors that are on little sticks that poke into the ground, and you don't even know they're there, and they're communicating wirelessly through a vast sensor network. You have little sensors along throughout the utility network that are performing functions. You don't know they're there, and maybe it's little bits of data, but when they're aggregated, the big data that comes out of it and that's then analyzed and acted upon is immense. And it's happening because those smarts, that intelligence is being pushed out that far in the network that even at that very, very end point, which is the sensor that tells us the temperature, the voltage, the pressure, vibration, or whatever, is able to already intelligently transform that data even before it gets to some some place where that data is used.
Peter, thank you very much.
Thank you, Stephen.